Okay, let us consider acidic buffer. As you know that, so what is acidic buffer? Acidic buffer is a combination of what?
Weak
Yes,
acid
sir.
and strong base, sir.
Yeah, weak acid and its strong base, right? Strong conjugate base. Clear. So here, what happens? The pH of acid buffer, okay, the pH of acid buffer can be calculated from the dissociation constant. As you know that, here we taken weak acid. For weak acid, so how we are going to calculate the pH by means of dissociation constant, right? So here, the pH of acid buffer can be calculated from the dissociation constant, that is Ka of weak acid, and concentration of acid and salt we use. Okay, concentration of acid and salt we use. Okay, here what is that? The combination of weak acid and salt, right? Simply what we call salt, nothing but conjugate base only, right? Acid and salt. Okay, if we consider the dissociation of these two, so dissociation expression for weak acid can be represented as, so HA, nothing but weak acid undergo dissociation gives H plus and A minus, right? So HA is nothing but what? A weak acid undergo dissociation gives H plus and A minus, right? Similarly, we have salt, right? So what about salt? Is it undergo partial dissociation or complete dissociation? Yes, tell me.
Complete, sir.
Yeah, it is complete dissociation, right? The first one is a weak acid, nothing but is it undergo partial or complete dissociation?
Partial.
Yeah, the first one is partial, right? And this is a salt, nothing but Ba. Okay, salt we can represent it by means of Ba. So salt undergo dissociation, nothing but complete dissociation. It gives B plus and A minus, right? It gives B plus and A minus. Okay. And now tell me, what about the equilibrium concentration of these two? Equilibrium concentration. What are the ions present at equilibrium? What are the ions are present at equilibrium? Any idea? And look at the
Sir, I
common.
don't understand, sir.
Yeah, can you just tell me?
Sir, I couldn't understand, sir, what you explained now.
At
Yes,
equilibrium,
sir.
okay? At equilibrium, what about the concentration of respective ion? I'm asking here. So we
It will
dissociation of
be equal, sir.
be equal. Okay, here the first case you consider just. So that is partial dissociation, right? That is partial dissociation. Second one is and it undergo complete dissociation. If we take mixture of these two, so at equilibrium stage, what about the concentration of respective ion? Hmm? Which ions present in excess quantity? So just look at the common thing here in both A minus, A minus. What is that? What is that?
Weak acid.
One word we have to prefer. I think you know
Anion.
that. Anion,
Conjugate,
Conjugate acid, sir.
conjugate base.
not like that.
Base.
One effect is there actually. One effect.
The common ion effect.
Exactly. Here, look at this common ion effect, A minus and A minus, right? So, presence of common ion. So, what about the dissociation of this? So, as you know that weak acid, right? That is weak acid undergo partial dissociation. But here we have salt, right? But we have salt. So it undergo complete dissociation. So that so B it gives B plus and A minus, right? It undergo complete dissociation in the sense it is completely converted into B plus and A minus ion, right? So A minus ion present in excess quantity, right? A minus ion present in excess quantity. But what about this ion? What about this first one? Can you see my screen? Can you see my screen?
Yes, sir.
Yes.
Yeah, tell me then. What about in first case? So as I told earlier, Ba is nothing but a strong salt, nothing but strong base, nothing but salt, right? Salt undergo complete dissociation, right? So if you take in a solution A minus ion, this A minus ion, so will be present in large quantity. I'm asking, what about this first one? What is the effect of this? Can you hear me?
Sir, your voice was breaking.
Okay. Now, can you hear me?
Yes, sir.
Okay. Just tell me then. Due to presence of a common ion, what about the dissociation of weak acid? What about the dissociation of weak acid due to presence of common ion?
It will become complete, sir. No,
Is
it
it
won't dissociate completely.
then further decreases, right? Or else,
Yes,
what
sir.
is that? What we call differs by presence of common ion, right? Further decreases. Dissociation is further decreases due to presence of a common ion, right? Due to the presence of common ion. Okay. We just take the dissociation constant, a constant with respect to these two reaction. So as you know that dissociation constant Ka, that is equal to what? Concentration of product over concentration of the reactant, right? Here the concentration of product nothing but H plus, the concentration of A minus divided by concentration of weak acid, nothing but Ha, right? Nothing but Ha. Here the concentration of H plus and A minus divided by Ha. Got it? If we just take the H plus outside, just take H plus outside here. So what you will get? H plus, that is equal to dissociation constant into Ha, nothing but weak acid, concentration of weak acid divided by A minus, right? So just take it out, H plus, that is equal to what? Dissociation constant into Ha divided by A minus. Call it as equation number 1. Call it as equation number 1. Got it? So what happens here? Just look at this equation 1. We can rewritten like that. The concentration of H plus, that is equal to Ka into acid divided by salt. Okay. Ha is nothing but what? Acid, right? The concentration of Ha is nothing but what? Look at this in this case. So listen. Can you see my screen? Can you see my screen?
Yes, sir.
Okay. Here the concentration of Ha is nothing but what? Acid, right? Acid. And A minus represents salt only. Salt only. Why? Because here look at this. We consider dissociation of these two, A minus ion. A minus ion will be present in large quantity. Why? Because it undergo complete dissociation, right? So it is a salt, it is undergo complete dissociation. That's why so A minus should be taken as salt only. Here. So here a weak acid is only slightly dissociated, as you know that, and its dissociation is further differs by addition of salt, nothing but Xa, right? Nothing but Xa provide ion A minus common ion effect. As a result, the equilibrium concentration of the unionized acid is nearly equal to initial concentration of acid only, right? The equilibrium concentration of A minus is assumed to be equal to the initial concentration of the salt added since it is completely dissociated, right? Therefore, the above equation, nothing but equation 1, we represent concentration of A minus by salt concentration. Okay, just rewritten like that. So you just put Ha, so Ha like acid and A minus nothing but salt only, right? Ha is nothing but acid, so A minus is nothing but salt only. Okay, now you just taking log on both sides. Okay, just taking log on both sides. What you will get? Log of H plus, that is equal to log of Ka plus log of acid by salt, right? We just take log on both sides. So we will get log of H plus, that is equal to log Ka plus log of acid by salt. Okay. Then multiplying both sides by negative sign. Okay. Multiplying both sides by negative sign. So what you will get? Negative log of H plus, that is equal to negative log Ka minus log of acid by salt, right? Negative log of H plus, concentration of H plus ion, that is equal to negative log Ka minus log of acid by concentration of acid by concentration of salt, right? So now what we are going to do now, as you know that Anderson equation, so accordingly we have to calculate the pH of the buffer solution, right? And look at this equation. So negative log of H plus ion, which implies what is that? Negative log of H plus ion.
Yes.
pH of
Yeah. Okay. Then negative log Ka represent negative log Ka. What is that? So negative log of H plus A, pH. Negative log of Ka.
pKa.
Exactly. Okay, look at this as negative log of H plus An, that is equal to pH, and negative log Ka, that is equal to pKa. Then what about the equation? So pH, that is equal to pKa minus log of acid by salt. Okay, pH, that is equal to what? pKa minus log of acid by salt. Okay, or else you just rearrange this equation. pH, that is equal to pKa plus log of salt by acid. Okay, just interchange this one. Your acid by salt is there, right? Acid by salt is there. So salt by acid which becomes positive. Your negative is there, right? Negative is there. So acid by salt is there. It is positive. So here positive is there. So that log of salt by acid. Okay, just rearrange this equation. You will get
Excuse
like
me,
this.
sir.
Yeah.
Sir, I have a doubt. When you're multiplying both sides by negative sign, right? So the whole LHS will be RHS will become negative. So shouldn't it be plus log of acid by salt? Because you are multiplying this one whole by the negative sign.
Yeah, that here negative log of H plus A, that is also here negative log of Ka, and here also it becomes negative, right?
But then there is a this one also division of log, right? So again that should become plus because there is already a negative sign.
So don't get confused here. I'll show you.
Yes, sir.
And look at this. This equation. So in this equation, all are positive, right? All are positive, or no?
Yes, sir.
So just multiplying both sides by negative sign, and this one will get negative sign, right? Here also, this is also positive, so it is negative. And here, positive sign is there. So this is also get negative, right?
Okay, sir. Now I got it. I worked it out. Thank you, sir.
Okay, and this is the equation what we called Anderson Hasselbalch equation with respect to acidic buffer. Okay, with respect to acidic buffer. So that is pH, that is equal to what? pKa plus log of salt by acid. Don't get confused. pH, that is equal to pKa. So pKa as in nothing but acid dissociation constant. If it is pKb, that is base dissociation constant. Here we have pKa, right? pH, that is equal to pKa plus log of salt by acid. Got it? And this is the equation, nothing but Anderson-Hasselbalch equation for acidic buffer. Got it? Acidic buffer. Okay. Similarly, we have to calculate with respect to basic buffer. Okay. Buffer equation for basic buffer can be calculated in the same way as that for acidic buffer. So here we are, as you know that basic buffer nothing but what? A weak base with its conjugate acid, right? Strong conjugate acid, nothing but salt only. So here we have to take a weak base, dissociation of weak base, that is representation of weak base, nothing but BOH. It gives B plus and OH minus ion. So here Pa nothing but salt only, nothing but conjugate acid. Okay. So Pa is nothing but what? Conjugate acid or else salt. So dissociation, it undergo complete dissociation to that B plus and A minus. Okay. To take base dissociation. So Kb, nothing but base dissociation constant Kb, that is equal to what? Concentration of B plus and OH minus ion over BOH, right? B plus OH minus divided by BOH. Clear? So just take out OH minus ion concentration. Just take out, wait a second, just take out OH minus ion concentration. So just rearrange this equation. That's nothing but the concentration of OH minus ion, that is equal to Kb into BOH divided by the concentration of B plus ion, right? B plus ion. Okay, Kb, that into BOH divided by concentration of B plus. Clear? We call it as equation number 1. The same thing what we are discussing as acidic buffer only. See here what happens. A weak base is only slightly dissociated, right? And its dissociation is further depressed by the addition of the salt Ba, which is provide a B plus ion, that is nothing but common in effect. As a result, the equilibrium concentration of the unionized base is nearly equal to the initial concentration of the base. The equilibrium concentration of concentration of B plus is assumed to be equal to the initial concentration of the salt added since it is completely dissociated, right? Therefore, the above equation 1 we represented concentration of B plus by salt concentration. Okay, salt concentration. Just remember the concentration of OH minus that is equal to Kb. BOH is nothing but base, right? BOH is nothing but base. Okay, B plus nothing but salt. So just replace it, no problem. Okay, OH, the concentration of OH plus N that is equal to Kb into a base nothing but BOH divided by B plus nothing but salt, right? Or as equation number 2. Okay, taking the same thing, taking log on both sides. So log of OH minus N, log of OH minus N that is equal to log Kb plus log of base by salt, log of base by salt. Okay, now you just multiply the negative sign on both sides, multiplying both sides by negative sign. What you will get, negative log of OH minus ion that is equal to negative log Kb minus log of base by salt. Okay, now tell me negative log of OH minus ion implies what? Negative log the concentration of OH minus N that is equal to what?
PKB.
POH, right? That is POH. Negative log Kb, negative log PKB. Okay?
PKB.
Yeah, just insert that those. So as you know that the negative log of OH minus that is equal to POH and negative log of Kb that is equal to PKB, right? Just insert this. So what you will get, POH that is equal to PKB minus log of base by salt. Okay, minus log of base by salt. Yeah. So or else you just rearrange this equation. What you will get, POH that is equal to PKB plus log of salt by base. Okay, log of salt by base. Called as equation number 3 is nothing but Anderson-Hasselbalch equation for basic buffer. Okay, so here, so for acidic buffer, pH that is equal to pKa, right? pKa plus log of salt by acid, right? So here POH that is equal to pKb plus log of salt by base. Okay, got it? Any doubts in that? Any doubts in that?
No, sir.
Okay. So now we are going to discuss some problems related to this equation. Okay. So firstly, we consider simple problem. So calculate the pH of a buffer solution containing 0.03 moles per liter of acetic acid and 0.1 moles per liter of sodium acetate. And here pKa for acetic acid is given, that is 4.57. Okay. Can you see my screen? Can I see my screen?
Yes, sir.
Okay. Just look at the problem here and which type of buffer it is. Is it acidic or basic?
Acidic buffer.
Acidic buffer. And remember one thing, if it is acidic, it will come within 7 only, right? 1 to 7, right? 1 to 7. pH of acidic buffer, nothing but 1 to 7 only. Okay, but you have to calculate the exact pH value for buffer solution, for that buffer solution. And we know that here weak acid is nothing but acetic acid. So that is nothing but 0.03 moles of acetic acid is there. And a salt, it's salt, right? Sodium acetate, nothing but sodium acetate. So that is 0.1 moles per liter of sodium acetate is there. As you know that acetic buffer is nothing but what? A combination of weak acid, nothing but acetic acid here. So and its conjugate base, nothing but sodium acetate. So right. So just follow the which equation you have to follow? Anderson-Hasselbalch equation. Which equation? So this is acidic buffer, right? Then which equation we have to follow to calculate the pH?
So pH is equals pH to is equals to pKa plus log salt
Mm.
concentration
by
of salt by acid.
Yeah, exactly. Okay, and look at this. Look at this. Here the given value is concentration of acid is given to nothing but 0.03 mole, right? The concentration of salt is given 0.01 mole, right? So just here, pK value is given already. So pK is nothing but what? 4.57. Just put these three values in this equation, and finally, what you will get, tell me. pH value. pK is 4.7 plus, yeah, plus log of salt you put 0.1, for acid you put 0.03. How much you will get, tell me.
So 5.092.
We'll check. 5.09. Okay, exactly. 5.09. Okay, pH that is equal to pK plus log of salt by acid. Here the value of pK is nothing but 4.57, and the concentration of salt is 0.1, and concentration of acid is 0.03. Before this value, finally you will get 5.09. Okay, 5.09 in the sense it will come the range between 0 to 7 only, which means it is acidic buffer. Okay, the exact pH is 5.09. Okay, any doubts in that? Any doubts in that?
No, sir.
No. Less than 1 minute is there. Rejoin with the same link. Okay. Okay. Just take this problem. Calculate the pH of a buffer solution containing 0.25 moles per liter of formic acid and 0.10 moles per liter of sodium formate. And here only Ka is given. Okay. Only Ka is given. So just convert it in Ka into pKa. Okay. Ka for formic acid is 1.8 × 10 to the power of -4. Just convert Ka into pKa, and here acid concentration is given and salt concentration is given. Okay, Ka is there, so just convert into Ka into pKa. Then you put which equation. This type of buffer it is. Is it acidic or basic? Is it acidic or basic?